Hi everybody, and happy holidays. I am here being Mrs. Willenbrock as usual, my same old self, making you a video to show you how to do U substitution problems involving trig. Okay. We've got a nice little review question here at the top to start things off. Hopefully you can look at that and work through it. If you want to pause right now so that you can try that first question, this would be a good point to pause. And if you don't want to pause, you can work through it with me. I'm going to let the u be x cubed plus 1, which means that my du will be 3x squared dx. And when I look at what's in my problem, I can see I've got what I need for the replacements, except for this extra 3, but I will deal with that by dividing by 3 and saying, okay, I'll have 1/3 du that's equivalent to x squared dx. What is, oh, my phone is talking to me. It just wouldn't be a video of mine if there wasn't some kind of wackiness going on. Okay, so 1/3 du to take care of the x squared dx. Rest of it is we have a u, and that particular u is to the 1/2 power. Now we've still got to do the antiderivative. So u 1/3 u to the 3/2 divided by 3/2 plus c, 1/3 times 2/3 u to the 3/2 plus c. And as usual, I'm running out of room, so how about 2/9, and we'll go back to x to the 3/2 plus c. We know that we're correct because if we take the derivative of this, we should end up with exactly what was in our integrand originally. Okay? So what's going to happen in a trig problem is one of two things. Either one possibility is you'll have a single trig function, okay, and I'm going to write that down, one trig function expression. Okay. And if that's the case, then u will probably not include your trig. If you look at problems 1 through 8, you can see on all of them I've got just a single trig expression. Cosine, sine, I got a secant squared, in number 6. But if all we have is one trig expression, that means there's no way to have any trig in our u. Because if we have trig in our u, just think about that for a minute. If u was, for example, the sine of x, then du would be cosine of x dx. And for a substitution like that to work, we would need to have both of those items in the integrand. So if you don't have a bunch of trig, if you don't have multiple trig expressions, then you're most likely looking at a problem where if it is a u substitution, the u substitution involves the argument of the trig, okay, what you're taking the trig function of. So for example, in number 1, grab this little screen capture toolbar here. Oops, can't do that with that over there. when I let my u be 2x minus 1, that means my du is 2 dx, which means I've almost got a nice representation of the integral. The only problem is I don't have 2 dx, I just have dx. But we know how to deal with extra constants. And so the substitution will look like that. So one type of u substitution with trig is about making it the trig function of something simple. Okay, so I don't know if you want to call it, it's not really an option. I wouldn't call it an option. It's not like we can pick. But case 1, our rewrite is going to take us to some trig function of u du. Now, one of the things that's tricky with u sub is we do so much work in the rewriting that we often forget I still have to take the antiderivative. So when I have 1/2 cosine u du, and I take the antiderivative of cosine is sine, so this would be 1/2 sine u plus c. And then almost done, 1/2 sine, and we go from u back to x, and here's this. Now, unfortunately, video-wise, you can't ask questions, but you might be thinking about questions, and a good idea would be to write those down, make a note of them, and either come see me in office hours and ask them, or oh, excuse me, send them to me in an email. If somewhere in your heart you're thinking, well, I don't have to do that, I'll just do this. Antiderivative of cosine is sine. Unfortunately, that's not an equal statement. The antiderivative of this expression is not this expression. And you say, well, how do you know that? Well, because if I take the derivative of the sine of 2x minus 1 plus a constant, I get the cosine of 2x minus 1 times another 2. Not equal to that. You're gonna have to most likely use a u substitution when you've got a single trig function, and you're going to need to use the u to represent the argument of your trig function. So as I look at all of these, I kind of see the exact same thing happening on all of them. Oop, even down here to 9 and 10. Even though sometimes when you look at something like number 7, you might think, well, what the heck am I supposed to do? I only have one trig function. So u is most likely needs to be the argument of that trig function. So du is 1/2 x to the negative 1/2 times dx, which it's part of our responsibility as fluent algebra students to understand when I see something like this, that that's the same as x to the negative 1/2 cosine x to the 1/2 dx. So I can see that this and this are here so that the rewrite will involve a 2du. Okay. With this video, you should be able to go through problems 1 through 11. Let me see, actually. And check your answers. Okay, so I'm going to stop the video here, and you should do 1 through 11, and then check your answers with the key.